Alright, so I'm just going to use this video to do a little bit of a review to our exam too. So hopefully you print out the review sheet because you might want to have that for class when you do our mini assignment. So I'm just going to kind of make sure I go through and explain each of the things on this review sheet. So the first thing is going through a story problem. So given a situation, could you identify the population, sample, parameter, all those types of things? That would be similar to in the part 1 notes, where we went through like example 1 here and identified the population, the variable, parameter, etc. So that's what that would mean. You go through the different types of bias. We've discovered the types of bias on a previous video. So in your notes there, that was on page 9 of the first set of notes. So could you do both? So if I give you a situation, can you tell me what type of bias is most likely to happen? Or would you be able to give me an example if I said if we're looking at finding out what % of people are interested in having a smoking section at a certain event? Give me a way that you could have had selected the sample to be biased. So I might ask you to give me a situation that falls into one of those biases. Recognizing a statistical question, that was the very first video that we did coming into this set of notes. Just understanding what a statistical question is. If I gave you a question, would you be able to tell me if it was statistical or not? Going on to having data, you determine what types of graphs and numerical summaries are appropriate for the selected variable. So in our very first packet, we focused on the categorical variables, where we did like pie charts and bar graphs. Then for numerical summaries, with percentages or proportions. Versus a quantitative variable, we talked about box plots and histograms, stem and leaf plots as being appropriate types of graphs. Then we talked about numerically, that's where mean and median and standard deviation. So just knowing which type you should be using based upon the variable that you have. Can you explain what type of graph might be considered a bad graph? So we looked at lots of different bad graphs. I'm going to pull up one here. If you remember, there was one about Obamacare that we had. So kind of going back and looking at that plot. All right, so we looked at this plot and figured out what was technically wrong with it. For this one specifically, it was the scale. So if we have sort of assumed that this is 0, that'd be about 6 million, which would put 7 million about right here. That was an example of a bad graph. If I were to give you a new bad graph, would you be able to tell me why it was a bad graph? Now, specifically looking at categorical data, could you create an appropriate plot, either a bar graph or a pie chart? Or be able to interpret an appropriate plot if I provided it for you? So could you create a bar graph versus could you interpret a bar graph as well? Can you calculate proportions or percentages? We did a lot of this in chapter 5 as well, where we just took our value divided by the overall sample size. So for this, we just did our count divided by the overall sample size that we had there. Could you compare 2 or more graphs such that we did in the homework? If you remember the example, we had the Ballard County, Boone County, and Scott County, and looking at their graduation rates. That was sort of an example of looking at those graphs. Looking at it, we could see where Scott County seemed to have a much different graduation rate than the other 2 counties that we had there. Then moving on to quantitative data, we did quite a bit more with quantitative data. So again, could you create the graphs? If I asked you to create a histogram or a stem and leaf plot, which could include a split stem, a dot plot, or a box plot, could you create those graphs? Now, if it said I gave you the graph, could you describe its shape and possibly identify outliers? But depending upon what type of graph you have, you can give me different types of shapes. So if we're looking at a histogram, or a stem and leaf plot, from either of those you'd be able to give me if it's symmetric or skewed, and of course which way as well. And from those you'll also be able to tell me if it's unimodal or bimodal or neither. If instead you have a box plot, the only thing you'll be able to tell me from that one is if it's symmetric or skewed and then which direction there. So we can't tell the unimodal or bimodal part from a box plot. And here we're just talking about given a graph, would you identify outliers? The mathematical idea will show up here later. Then can you calculate the mean, the median, the percentiles for Q1 and Q3, the min, the max, the range, the IQR and standard deviation. And again, of course, you're going to be given formulas for standard deviation, IQR, and then that index formula for the Q1 and Q3. So you'll have those formulas. Now, looking at all of these values, can you not only calculate them, but can you interpret them? Can you explain to me what they are and understand what kinds of values they can be? For example, if we were looking at getting from each individual the number of pets they have, would it make sense for the mean to be a decimal? Well, the mean's an average, so the decimal would be perfectly fine there. Does it make sense for them? Could the median be a decimal? Well, it could be like 2.5, for example, if I had an even sample size and had to average those two middle numbers. But, right, and so versus understanding like the min and max would have to be whole numbers because they're actual values from the sample. So just understanding what types of values you can get and what those numbers actually mean as well, right? So the median cuts the data in half. So half falls below it, half falls above it. Q1, 25% below it. Q3, 75% below it. The IQR gives us that middle 50%. Standard deviation gives us that typical distance from the mean. Understanding you know what those values are. That also leads into the next bullet of can you completely describe our four characteristics in the context, that shape, outlier, center, and standard deviation. We did that a couple of different times in the notes, the more recent notes, with the quantitative stuff here. So our first example was the shoes example here on page 8, where we have the shape, outlier, the mean and median, and then that interpretation of the standard deviation. You then also had that in the most recent video, where we went through and did that interpretation as well. So that's what I mean by those four characteristics in context. Means like here we're talking about Stat 113 students scoring the scores on exam 2. So we're talking about the particular problem we're interested in. Can you compare multiple graphs? This would be like what we already started doing in the standard deviation activity, and that will continue to do. So just showing you those. If I gave you two graphs, would you be able to tell me which one has a larger standard deviation and why? Or if I didn't also give you the mean, would you be able to tell me which one had a larger mean and why as well? And then finally, can you mathematically determine if there's an outlier with the IQR or standard deviation methods? These are things that you should be able to do for exam 2. Now again, there's that practice add-on Canvas. Let me show you that again. So on our home page, just go to that practice circle. There's the exam 2 practice. The solution will also become available, I believe, about on Monday. But so working that again without your notes, it doesn't cover every specific example. These are all old test questions that I've used before. So it gives you a place to start. You kind of see some example problems to work through there. But again, that's not everything. So that's why it's good to have this review sheet to find out the other types of questions that you might see as well.